Welcome to my channel. Your tutor Mariam is here. It's a 40th video of Introductory Physics 1, and the second video I'm going to talk about the laws of motion. In the previous video I talked about the force and Newton's law, and in this video I'm going to solve a couple of examples. If you are new to Introductory Physics 1 and like to learn more, hit the subscribe button and like to learn more. You ready? Let's get started. In the previous video I talked about force. Let me remind you what is force and what is a Newton's law. Force is an interaction between the object causes any changes in the velocity. Let's say I have two charges, one is positive, the other one is negative, and they apply a force to each other to attract each other, right? Another example can be the gravitational force. While I'm sitting down on my chair, gravitational force is applied on me. First, Newton's law says that if no forces apply to the object, that object remains at the rest or move with a constant velocity. That means that if object doesn't move at all, it's gonna remain at the rest, so it doesn't move forever, or if it is moving, it's moving with a constant velocity till another force applied. The second Newton's law says the net force applying on the object is equal to mass times acceleration. Also explain that this Newton's law, when you're gonna take it as a derivative, mass can change or velocity can change. And also I mentioned that in Introductory Physics 1, you usually don't deal with mass. You only deal with changing the velocity. That means you're dealing only with the acceleration. The third Newton's law says if two objects are interact, one object apply force to the other object apply the same force, same magnitude, but in the opposite direction. It's telling me there should be a minus F here. Now let's look at a couple of examples. So first example, Alex pushes a 3 kilogram box with 6 Newton of force. What is the acceleration? So it's like I have a box here and it doesn't mention the direction, but I'm gonna say to the right side, and there should be a force right here. So M gonna be 3 kilogram. My force gonna be 6 newtons, and then I'm looking for the acceleration, right? Based on the second Newton's law, F equal to M times A, right? So my F gonna be 6, M gonna be 3 times A, right? And then by simple math, I can find the acceleration as a 2 meter per second square. And be careful, this M here is meter as a unit, and this guy right here is my mass, and the unit is kilograms or grams. Let's look at the second example. A hammer exerts a 32 Newton force on a nail. What is the force the nail extracts on the hammer? So in this question, it's like two objects interacting to each other, right? A hammer and nail. And there is no other force applying between these two objects. So that's telling me we are dealing with the third Newton's law. Based on the third Newton's law, F12 is equal to F21. So they have the same magnitude and value, but in the opposite direction. So it's going to be minus F21. So if my F21 is equal to 32, then based on the third Newton's law, F21 must be minus 32. B gonna be correct. Now let's look at the third example. So here is like Sara have a box with a mass of 1 kilograms. So my mass here gonna be 1 kilogram. And then is Sara apply a force to the left, and this force gonna be 20 newtons, right? And then Mark push the same box with a 50 to the right. so there is another force to the 50. I'm gonna call it as F2, and this guy gonna be F1. And the first part is said, what is the net force on the box? Let's go back to the second Newton's law. Based on the second Newton's law, F is equal to ma, right? And that is the sum of over F, correct? Now let's see what I have. On the right side, I have 50 newtons, and then on the left side, I have 20, right? So obviously, 50 is bigger than 20, correct? So at the end, box gonna move in this way, right? Because 50 is bigger than 20. So my F total gonna be to the right. So this is the direction of total force. Now let's calculate the value. So on the right, I have 50. On the left side though, I have 20. So the total gonna be 30. And that's gonna be my F as a total force. Now let's calculate the acceleration for the second part. My total force is 30, right? M is 1 kilogram, and I'm looking for the acceleration. And here, my acceleration also gonna be 30 meter per second square. And that's gonna be my final answer. Now, let's look at a similar example. Here, I have the same box again, so mass is like 1 kilogram, and then Sara pushed the box in the right side, so that's my F1, and also Mark pushed the box to the right side, so that's going to be my F2. Now I need to calculate the net force on the box. Again, my net force here, F gonna be M times A, right? But this time, these two forces are in the same direction. So here is like 50 plus 20 is equal to 70. And this is my total F right here. And now for the acceleration, I have 70 equal to 1 times A, and then A gonna be 70 meter per second square. And that's gonna be my final answer for both. Now let's look at another example that is similar to this. So here again, Sara and Mark push the box in the same direction. So my F1 gonna be 20, my F2 gonna be 50, but here my mass is 1 gram. So please pay attention about units. If my units is gram, I have to convert it to kilograms. And from the previous videos, we know that 1 kilograms equal to 1,000 grams. So here, first I'm gonna calculate the total force. My total force gonna be 20 plus 50, so that's gonna be 70 newtons. And now I need to convert the mass. So my mass here gonna be 1 grams times 1,000 grams and 1 kilograms. So these grams and these grams as a unit's gonna cancel out, and then my mass here gonna be 10 to the minus third kilograms. If you don't know how to do this conversion, I already made a couple of videos about the concept, and also I solved a couple of examples. I'm gonna put the link below and also on top. Feel free to watch them. So now for the acceleration, I have force as a 70, mass is 10 to the minus third times acceleration. So acceleration gonna be 70 divided by 10 to the minus third, and acceleration gonna be 70 times 10 to the third meter per second square. And that makes sense because acceleration should go up when the box is lighter compared to the previous example. I hope this video helped you to understand this subject better. In the next video, I'm gonna solve the complicated examples. If you like my video, hit the like button, and I'll see you in the next video.